Hi, and welcome to the first tutorial in the SIDD tutorial series. In this tutorial, we'll be walking through the steps involved in installing the SIDD microsimulation model onto a new workstation. In order to begin the process, you really need to get access to the installer file. I've got it on the desktop here. You can obtain it through the SIDD website at www.simdynamics.org. Once you've downloaded the installer file, the installation process is really quite easy, but there are a couple of additional steps that need to be taken before the model will be ready to use. So let's make a start. If we double click on the installer file, you obtain this regular installer sort of application. Check that the model variant is the one that you were after, and then click next. You receive a user license. It's fairly standard, but I encourage you to take a read through it. It defines your rights and obligations in relation to using this free software. If you're happy with it, click I accept and next. Then you have to define a destination folder. You can just type something in like temp, or you can browse to the folder with a standard Windows Explorer screen. We'll just select temp here, click OK. Note that if you use the Explorer, it will append NISA/SIDD onto the end of the chosen folder. That could be inconvenient. I'll just delete those here. Click next, and the installer will work its way through. Once it's done, you can click finish, and the model is all installed. If we now have a look at the temp folder, you can see that there are 6 items here, 3 of which are uninstall files. If you want to get rid of the model, simply double click on the uninstall.exe. It will delete all of the files that have just been installed. It won't uninstall any files that you have altered or created, either with the model or without. Those files will need to be deleted by you manually. So otherwise we have a documentation folder, Fortran folder, and a model folder. If we start with the documentation folder, you should find at least 3 files. The Linda manual is really a main user manual. If I open that up, you'll see that it's got quite a lot of content in there that will be useful in whatever circumstance you're sort of interested in using SIDD. I should mention that SIDD stands for Simulator of Individual Dynamic Decisions. This is a framework, if you like, for implementing a dynamic microsimulation model based on dynamic programming techniques. The idea that we've sort of adopted is that each time you parameterize this framework for a different policy context, for example, the UK in 2011 or 2016, it receives a different name. And the UK variant we've named Linda, the Lifetime Income Distributional Analysis Model. But as I say, although this publication here is specifically set up or adapted for the UK context or a UK parameterization, it really does include a lot of information that you'll find useful even if you are trying to reparameterize this SIDD framework for a different context. So if we open up the bookmarks tab, just quickly walking through the manual, there's an introduction, a model setup section 2. This is the section that we're really working through today. Um, then there's a section on using the model on a cloud service. That's a subject for another tutorial. It's very, I think it's an exciting sort of area that we're developing in relation to the model's use. There's altering parameters. Now these parameters here are all can all be altered through Excel user forms. It's designed to facilitate parameter variation, at a very high level, but it's only really set up for the UK context. So other country contexts won't really be applicable here. There's then running the model on a local computer. Again, another subject for another tutorial. Simulation output. Both the model produces both microdata for the dynamic, evolution of a population cross-section. Here, really, the idea is that the model is outputting a full set of panels data for the evolving cross-section. It also generates a bunch of default summary statistics, which it outputs into Excel files. And then there are optional summary statistics that you can direct the model to create. So the model really, just as a quick overview, it loads in inputs from Excel and then it generates a series of outputs, some of which are in a simple text format. And those data are really the panel data that represent the evolving circumstances of the population cross-section. And it also produces a series of summary statistics, and those statistics tend to be output into Excel. So that's the output of the model. Then there is a section on methods of best practice use of the model. And if you are new to microsimulation, and even if you aren't, I recommend that you take a read through that. Section 8 looks at adjusting the program code, and here the text is entirely focused on altering the tax and benefit code in the model for reasons that I'll come to in a moment. And then there's a couple of appendices. So if of interest, I recommend that you take a look through this publication. And if you've got any comments on anything, this video or the user manual or anything else, please don't hesitate to contact us. So that's the user manual. Then there's a programming guide, and this programming guide, as opposed to the focus on the tax and benefit code in that Linda user manual, the programming guide is really designed to look specifically at the model as a whole. So this guide is likely to be of use to you if you get the full variant of the source code of the model. Now, I should note at this point that the version of the model that you can download directly from our website includes only the source code for the tax function, tax and benefits function in the model. If you want access to the full source code of the model, we can do that for you, but you'll need to fill out an application form, which you can find on our website. And then we'll review your application and get in touch with you with further directions about how to access the full source code of the model. Finally, there's a technical description of the model, and this technical description really just goes through all of the characteristics that the current version of the model is adapted to reflect. So, things like marriage, divorce, number of children, wage potential, labor supply, pensions, rights, and so on. It describes all of those characteristics, and it describes how those characteristics are simulated through time. So if you want a sort of well, ideally accessible uh, uh, publication for understanding exactly what it is the model is generating, then this is the place to look. So that's the documentation as it stands at present. Next up, we have the Fortran subdirectory. Now, the model is entirely programmed up in Fortran, and so the source code of the model is all stored here. The subdirectory here has two other folders in it. In the version that you download from the website, there's a redistributable files directory and a taxes directory. Now, the redistributable files are really for people who are wanting to implement and use the MPI directives that are built into the model. Now, the model, for those of you who are familiar with such things, the model includes both OpenMP and MPI directives to take advantage of parallel computing possibilities on the particular hardware that it's being run on. Some of you will want to take advantage of the MPI stuff, particularly if you're running on a supercomputer or cloud computing. And so we include the redistributable files, which you could also just as easily download directly from the Intel website here for you. If you wanted to use MPI, double-click on this installer and it will install the MPI redistributable files. So that's the prepackaged stuff. Then we've got the taxes code. Now, I'm assuming pretty much zero prior experience in these tutorials. So the files in here will be familiar to some people and won't be familiar to others. I'll just describe them quickly now. There are a whole bunch of files here that have an F90 extension. These are Fortran program codes. And they can be read in any text editor. Now, this source code is organized in via a programming environment, and we typically use the Microsoft Visual Studio programming environment to implement changes to the code and to create new code and so on. Now, Microsoft Visual Studio at present is freely available in a community version from the Microsoft website, and it's really fantastic. I'll just double-click. Once you've got Microsoft Visual Studio on your computer, I should mention that one further thing you'll need is the Intel Visual Fortran compiler. Now, this will cost you a little bit of money. You can look it up on the Intel website. It's fully integrated with the Microsoft Visual Studio environment. For our purposes, we don't need anything very fancy in terms of the Visual Studio. You can just get the very standard, the very basic variant of the Intel Visual Fortran compiler. I think it's called currently Intel Visual Studio Composer. If you want to also take advantage of SIDD+, you'll need the parallel composer. And if you want to also program up MPI directives, then you'll either need the cluster variant or you'll need to get the MPI library separately. In our case, we have gone for at the current time, what's called the composer version for Fortran compiler, and we've added in the MPI libraries, and we've done that because the MPI libraries are at the present time freely available for academic users. So once you've got those things installed, you can just double click on this SLN, taxes.sln file, and that will bring up the Visual Studio environment. I'm working on my my laptop here at the moment, so this actually takes a little bit of time to load up. So while we're waiting for that to load up, I'll just walk through the other folder of this of the SIDD application, and that's this model folder. Now, the model folder includes all of the files that the model needs in order to run. It doesn't need the documentation, and it doesn't need the Fortran subdirectory. For those of you who might be a bit confused, thinking, well, I thought that the source code for taxes was in the Fortran subdirectory. That's true. The source code for the taxes uh, um, uh, functions is in the Fortran subdirectory, but that's just the text version of the source code. What happens is that you use this programming environment to program up new code. And then once you've decided, okay, well, I'm happy with this code now, you need to do something called compiling. And what that means is that this Intel Visual Fortran compiler takes your text code and it translates it into instructions that the computer can readily understand and operate on. And so the product of that translation then appears in this model subdirectory here as these taxes .dll.exp and .lib. DLL stands for Dynamic Link Library, and that's actually the SIDD.exe file makes calls to this taxes.dll file in order to conduct the tax and benefit calculations that are needed by the model and that are central really to the model's running. And then the taxes DLL file returns to this SID.executable file the results of the calculations that it performs. So just to recap, your text files here are translated by the compiler to produce these files here, and it's these files here that are needed by the program. The files in this taxes folder aren't actually needed at all, and it could be in fact deleted, and the model would run just fine. But our programming environment is now loaded up, so we'll skip back to that now. And what we need to do here is set this programming environment up so that it's ready to use on the machine that you've just installed the model onto. And to do that is actually really quite easy. If we go to I don't know how your Visual Studio will look. It may not look like this, but what we're looking for is the Solutions Explorer. If you can't see it, just go to View, and it's the first item under the View menu in Visual Studio. Once you've got the Solutions Explorer open up, you can see this file structuring here. At the very root is something called a solution. Within the solution, each solution can include multiple projects, and indeed you'll see multiple projects in the full version of the source code for the model, but this is a limited version of the source code, so we only have the taxes project in that solution, and then we have a series of subdirectories. The first two are empty, and the third is source files, and that includes all of the source files that the model uses in order to generate taxes and benefits. So these are, as I say, they're just basically text files. You can open them up by double-clicking on them, and you will see a bunch of text code that you can then scroll through and edit as you like. So we need to set this programming environment up so that the compiler knows where to send the compiled version of this source code. So to do that, we right-click on this projects icon, and we go to Properties. And once we've opened up the Properties page, make sure that you're under Configuration. You've got all configurations selected. There is only one platform. We used to support 32-bit programming, for those of you who are familiar with such things, but we've gotten rid of that because virtually all computers that this model will be run on now are 64-bit anyway. And what you're looking for is under the configuration properties here, go to the General tab, and we just need to change this output directory. And so we've put this model into the temp folder, and we want the compiler to be sending our compiled code out to temp, the temp folder, and then the model folder inside the temp folder. And that's it. We just hit OK, and it's all set. It's all done. Just a very brief point. There, you should have two windows here, one of which is a solution configuration, and the other is a solution platform. You don't need to worry about the solution platform because we only have one, as I say, 64-bit. But the solution configuration has both debug and release variants. Make sure that it's selected to the release variant here. The differences between these two are really a subject for another tutorial. So now we'd like to test that this is set up properly. So click this Save All button, the 2 disks button, just to save the changes that we've made. Now we'll go back to our model subdirectory under temp. Note the time and date of the of these taxes files here. They're set for the 18th of the 7th and at 1401. Now they're the files that we received when we installed the model from the web, downloaded from the web. If we now go to build and rebuild our solution, you should see an output window open, and then a series of lines pop up, basically telling you how the compiler is working through your source code and translating it into these machine operable files. And so it's coming down here, it's almost done, it's just finishing up, and it's linking things, and you should see right at the end, rebuild all, 1 succeeded, 0 failed, 0 skipped. So that's all worked just perfectly. If we look now in our model subdirectory, you can see that it's now today's date, the 19th of the 7th, and it's today's at the around about right now's time, 9:17. So that's indicating that the translation A worked, and B, it sent the translated files where we want them. So that's all working now. The programming environment is all set up. We can close it down. I should note that if you're not intending to ever change the program code, you could just as easily delete this Fortran folder altogether. It isn't needed by the model. It's really just there if you are likely to want to alter the tax and benefits code. All right, so now looking at these model folders in a little bit more detail, I'll just arrange by type. There are 3 subdirectories in this folder, and then a whole bunch of other files. The analysis files subdirectory or folder includes a whole bunch of templates into which the model writes the summary statistics it is directed to evaluate for any particular simulation. The base files folder includes a bunch of additional parameters, model parameters, that the model requires in order to run a simulation. And we'll come back to that in a moment. The simulation subdirectory is where the model writes its the output that it is directed to generate. So when you ask the model to undertake a particular simulation, you define the simulation, and you're also asked to define a name for the simulation. The model will produce a new subdirectory under this simulations folder with the name that you've given the simulation, for example, low_taxes. And then it will put all of the outputs that are generated for that particular simulation in that subdirectory, low_taxes. That's the simulations directory. Then there's the SIDD.exe file, which is the main executable of the program. The comms.dll is a file that communicates with Excel primarily. This is the MPI dynamic link library that you need, even if you don't want to use the MPI library. It's this DLL is needed, and that's why we've copied it into this main model subdirectory. A similar file for the OpenMP directives, and then taxes.dll, which we've just created using the programming environment. There are then some files with similar extensions, library files, and EXP files. Finally, you've got well, almost second to last, I suppose, you've got a couple of Excel files, including model parameters. This job file is the central repository, if you like, for all of the model parameters. This is the first file that the SIDD executable will look for when it's actually being called to run a simulation. And these base parameters are just a store for the base parameters that we deliver with the model. Finally, there's a Word document, and this Word document evolves each time we make some changes to the model. We record what changes we've made since the last model variant. So if you update the model at any time, you'll be able to look in this file to see exactly what changes have been made since the last version that you've had, and you can just read through those. They can be somewhat cryptic at times, but usually these changes boil down to bug fixes or new functionality. So that's that. So we have one additional step to perform before the model's ready to be used. And that step involves looking at these base files. Now, the SIDD program is designed to generate, it is designed to project the evolving population cross-section through time. And it does that by starting with a reference cross-section. And the characteristics for the reference cross-section need to be fed into the model so that the model knows, you know, what the starting point looks like, really. And so for the UK variant, those initial starting point data are drawn from a survey called the Wealth and Assets Survey. Now, the Wealth and Assets Survey is available from the Essex Archive for free. You should make sure that you get the extended version of the Wealth and Assets Survey rather than the standard, just to make sure that you have access to all of the data you need. But we don't actually deliver those data to you. We're not able to for what I hope are obvious reasons. Nevertheless, we do provide a stata_do file, which is designed to extract those data for you. And so to perform that task, basically you just double click on the pre-packaged Stata do file, and that will open up this Stata text editor. And what we need to do, this program is pretty much all set up for you. Well, actually no, I'll carry on here. The only things that you really need to worry about here is the fact that you need to change the model directory to the location where you've put the model. This is temp/model, so that's all set. And you'll need to worry about where you have stored the wealth and asset survey data. You'll need to change this. And for me here, I have that wealth and asset survey saved in a data file and a UK and a wealth and asset survey and Stata. So I just copy that and I'll paste it in here. Finally, you may want to check the names of these various Stata files. There's a Wave 3 household file, a Wave 3 person file, a Wave 2 person file, and a Wave 1 person file. If I look at my Explorer window here, I have a Wave 3 household file, and it's called the same thing as it's called in the text document here, a Wave 3 person file, Wave 2 person file, Wave 1 person file, so we're all set to go. So, so the only other thing that you might think about here is that is this final line down here, line 55. Now you'll note perhaps that under this base files subdirectory there are two additional folders. There's a principal and a negative. Now in the model that we deliver to you at present, the principal variant is designed to reflect what we think is a reasonable best guess at conditions into the future, and the negative is exaggerated in certain selected ways. So it includes particularly long lives into the future, high rates of unemployment, and so on, low rates of growth, and so on. This Stata file here will generate an output to the principal directory, as we'll see in a moment, because we've got this output directory defined as UK 2011 principal just here. And if you want to use the negative variant, you'll need to copy and paste the output that's generated for the principal into the negative. If, in contrast, all you want to do is run with the negative scenario, then you would just change principal to negative in the Stata file here. In any case, we're ready to go, so we'll save it and hit execute the do file, and that will start. Oh, actually, so I've made a little mistake here. Just delete that, save that, and then click execute, and that will start your Stata file off. Depending upon how fast your computer is, this could take a little while. On my laptop, it does take a little while, so I'll pause it here and come back to you in just a moment. Okay, so my state is finished, and when it finishes, you should see it run. If it does run all the way through, you shouldn't see any red, error messages pop up, and it should come up with this large comment saying end. So that's all done. So we can close down Stata. We don't need to save anything there. If we look in this principal file, you'll see that just a moment ago, this starting_pop.dat file was generated. This is the file that I was referring to you as before as recording all of the microdata for the reference cross-section from which the model projections are made. So this is the file that the model will look for when it's trying to populate its initial population cross-section. So that's it. The model's all set. It's all ready to go. The only other minor thing that you might check, just to make sure that it's all working as it should be, is that if you double click on this this data file, this WAS data file, this Stata data file, and you look at the data, you go all the way down to the end. I've got 20,246 observations there. That should correspond to the number of observations that the model expects to take in. And to check that, if you open up your job file, it's opening up, and you look in cell E21, 20,246. So the number of observations that the model expects to take in is exactly equal to the number of observations that our base survey data have in them. So it's all worked, it's all good. We can close that down, we can close that down, we can close this down, and we're all ready to go. How to run the model is the subject for probably the next tutorial. So look forward to speaking with you again then. Bye bye.